Here it is the structure I considered for activity 1. It exactly addresses the requirement by activity 1. Now we have the raw structure. You see, we just have about the different features and items that we have. Here, column L, that I have named number of guests, is the final output that we expect from the simulation model. Here we have the simulation of 1,000 weddings. So we are gonna see for 1,000 times, according to our model, what would be the number of guests who are coming. Okay, I have considered three parameters, three variables, three factors. One is the people who are SVP'd as solo. Here is the people who have RSVP'd with a companion, and here the people who didn't reply, didn't respond. So NR is no response. Why I didn't include 0 RSVP? Because according to the experience of the wedding planner, the people who announce not to attend the wedding, rarely they would attend it, so they will consider them as 0 guests. So the next step that we want to do, we need to generate the random number associated with one RSVP, and we want to simulate that, for example, in the first wedding, the people who have RSVP'd as solo, what would be the associated number to them. And so remember, you can do the model in other ways as well. If you have made another model and you think it works, I suggest stick with your model and continue with that. If you are not sure about that thing, you just reach out to me and we can discuss it together. I can check your model and tell you if it works or not. And another thing, to see if your model works or not, you can continue your model with the elaboration that I'm offering you in this video to see if your model is practical or not. I'm just giving you the heads up that there are also other ways to do the modeling. And also I should tell you that the model that we are doing is not the most accurate one, because as you will notice, I have considered only one column for the 25 guests that who have RSVP'd as solo. Um, I will tell you about that more, because here we assume that they all are gonna be the same and just one column can represent all of them. I'm not saying that it's gonna distance us too much from the correct answer, but it is worth it. You know, the type of error it imposes in comparison to the saving it offered regarding the calculations is justifiable. But if you have simulated in a way that for each of these guests you have considered a column, that would be absolutely correct and in fact better. Okay, so what we want to do here, since one RSVP, two RSVP, and NR, according to the explanation that we had, all are discrete probability distribution, so we need to first have random number for each of them. As you have know, we are gonna do it with this, and I'm gonna populate it. And so and remember, while I'm doing this video, to make the video short, I'm gonna do a lot of the things that are repetitive without showing you. But here I'm telling you, here it is random and it is the formula, and we are gonna populate all the cells. Here we have ran, here we have ran, and here we have ran, and all are the same. If you check the PowerPoint, you will find that regarding the guest, the people who have RSVP'd as solo, 75% there is a chance they will come alone, 25% chance they will not come, and 5% chance they will come with a companion. So if I want to draw the probability distribution model, it would be this 75, and we have this, and it is 1. We have 20, 0.20, 0, and we have as 2. So now we have this discrete distribution probability, and so according to this, we are gonna now generate random number, and in that situation, we would simulate the number of people who attend the wedding and they have RSVP'd as solo. So according to what we have learned together before, and also some of the cases that we have done, we can use nested if, and also we can use if s. I'm gonna use if s, and the first one I'm gonna write is this: if fs, the first one, the random number, and I'm talking about that ranges that we always have talked about, it fs is smaller than 0.75, the value would be 1. If f, not s, f3, sorry for my mistake, f3 is smaller than 0.95, it would be 0, and f3 is smaller than 1, it would be 2. So now we have the simulation for that. For example, for the first one, that it says, for example, they attend alone. But remember, as I told you, we are using one column for all the 25 guests who have RSVP'd as alone. So what we get here, we need to multiply it by 25, because as you can see in this table, we have 25 of these people. I agree with you if you suspect it, because now we consider it all of them are acting in the same way. Absolutely, that's correct. So that was the reason I told you, if you assign one independent column to each of them, that would be right. But again, it can help us, especially that we are doing 1000 simulation, and even if you calculate and if you do the simulations for larger number, for example 5000, this error would be smaller. So now I have this and I get the job done for RSVP. After that, we do the same thing for 2 RSVP, but the difference with 2 RSVP is that the number of guests who have RSVP'd with a companion, it is not 25, it is 60, so I make this 60, and also the probabilities are different, and you can check the PowerPoint to see the associated probabilities of 2 RSVP. If you check the PowerPoint, you will notice that the probabilities associated with this are 90%, 5%, and 5%. So if I want to draw the discrete probability distribution, it would be here. We have, again, 3 different numbers, and the scale, absolutely, I missed the scale. Here we have, they come with a companion, so they are 2, they come alone, they don't come. It is 90%, it is 5%, and it is also 5%. So now we have these probabilities, and now we are going to generate the random number. We updated the 60, that's correct, and H3, the random number that here it is generated, but here we are assigning the ranges, so it would be 90, and when it is 90, the number of guests would be 2. When it is smaller than 95, the number of guests would be 1, and otherwise the number of guests would be 0. So now we have it, and we populate the part, and the last part we go for the invitations that they didn't send any reply. The first things that we should do is that they are only 10, so we have one column for these people, and after checking the PowerPoint, you should come up with the correct numbers and calculations here. After checking the PowerPoint, you will notice that the probabilities that we have 80%, we have, I hope I'm right, 15% here, and 1 for 5%. But, and I'm just updating these things. So 80% they will not attend when they have not responded. 15% they will attend solo, and 5% there is a chance they will attend with a companion. Okay, now we go here to update the numbers and parameters here. When it is smaller than 80%, it is 0. When it is smaller than 95%, it is 1. And when it is smaller than 1, it would be 2. I hope I don't have any typo. Smaller than 80%. 95, 1, and 1 is 2, correct. Okay, now now we can do the final calculation. The number of guests that we get for the first wedding would be these people here, plus these people here, and plus these people here. And when we populate it, we come up with this result. So now, according to this simulation, as you can see, for example, it says that in the first simulated wedding, the number of guests is 165. In the second simulated wedding, the number of guests is 145. In the third one, it is 85. So just check the differences. That's the part that simulation is very reliable, because it considers all the cases according to repetition and their probability. And as you can see, we have 165 and also we have 85. And that's the reason making decisions in such situation is not easy, and we need some support from decision science.